All right, here we go. Let's take a look at Unit 6, non-real numbers. This is a quick review. Kind of threw another one of these hilarious comics up here. Did you figure this one out? What does this equal? Well, on top, what is the square root of negative 1? That is the definition of I. What's on bottom? 2 cubed is 8. So what does this mean? That's right. That is I over 8. Love it. Love it. All right, let's do a quick review here. We start off with imaginary numbers. And what in the world are imaginary numbers? Well, let's go from why we need them. If we need to take the square root of negative 49, it used to be impossible. These are non-real solutions. Why? Because 7 times 7 is 49. Negative 7 times negative 7 is positive 49. How in the world do I get that negative 49? So what we came up with, or not we, a long time ago they decided, they came up with I times I. Well, yeah, that's I squared, but what is that really going to mean? We're going to have that equal negative 1. So I squared equals negative 1. This is the key to it all. So now what I can do is I can say 7I times 7I is what? That's going to be 49I squared. And what is I squared? It is negative 1, so that becomes negative 49. So this has a square root of what? Of 7I. So those are imaginary numbers. From there, we kind of get this whole cycle of numbers. If you can find I squared, or just memorize it or know it, that that's negative 1, then what is plain old I? Well, it's the square root of that. Then what's I cubed? Well, I cubed is just like saying I times I squared, isn't it? And that would be I cubed, so I cubed would be negative square root of negative 1. And then I to the fourth is going to be what? It's like I squared times I squared, or I cubed times I, however you want to do it. I think I squared times I squared is easier. It's positive 1. So this is the cycle of numbers. I to the fifth starts over at I to the sixth is I squared, I to the seventh is I cubed, so it's a cycle that goes forever and ever and ever. Awesome. So complex numbers were part real, part imaginary. So the A is the real part, the B is the imaginary part, and we can do all kinds of stuff with this. Say you have 2 plus 3i. What does that mean? Well, this is the complex plane right here. So instead of our normal Cartesian plane, this is a complex plane because it's real and imaginary. It's got both in there. To plot a point, no problem. Go over 2, up 3. That is the point 2 plus 3i. So we can plot points, and what else can we do with these? All kinds of operations of these complex numbers. Add, subtract, multiply, and divide. So when you add them, no worries. You just add the real parts. 3 plus a negative 2 is 1. Then you add the imaginary parts. Negative 4 plus negative 8 is negative 12i. So no problem there. What about subtraction? Just be careful when you subtract. I kind of rewrite it because you're subtracting all of this. So it's really like saying minus 6 plus 8i. And again, once you do that, you're golden. You just go ahead and say, oh yeah, my real parts are negative 3. My imaginary parts are 12. Boom, there it is. Love it. How about multiply? So this is that idea of double distribute, or some people call it FOIL. So we can do this no problem. 2 times 4 is 8. 2 times negative 5i is negative 10i. Then we've got negative 3i times 4 is negative 12i. Negative 3 times a negative 5 is plus 15i. I times I is I squared. So we got to do a little simplifying here, though. So the middle terms, no problem. Negative 10, negative 12, that's negative 22i. Plus this 15, but what was I squared? If you go back to the last slide, what was I squared? Remember, it's negative 1. That's the whole idea of this. So this is really saying minus 15 at the end. So you've got 8 minus 15. We're looking at negative 7 minus 22i. So be careful with that. Simplifies down to that right there. Excellent. Moving on to division. So we want to get this I out of the bottom. So we're going to multiply by its conjugate. That's just a fancy way of saying change that middle sign. It's the exact same thing. Change the middle sign. So we're going to use a difference of squares for this. Awesome. So I'm multiplying by 1. Nothing changes. So what does this equal? Well, if I do the FOIL on, if I FOIL at the bottom, it's going to be 2 times 2. 2 times 5. So I'm going to look at 4 minus 10i. Then I'm going to say 5 times 2 plus 10i. That's the whole goal, is those cancel. And then I end up with minus 25i squared out here. Awesome. On top, put those in parentheses and do another FOIL. 7 times 2 is 14. 7 times negative 5 is negative 35i. Then we got negative 2 times positive 2 is negative 4i. And negative 2 minus or I'm sorry, times a negative 5 is that I squared. So it looks crazy. We got a lot going on over there, but no worries. Let's combine this down a little bit. So I'm gonna come down here and say 14. The middle turns into what? Negative 39i on top. Plus, remember what's happening here? This is 10i squared. This is that negative 1. On bottom, my middle terms cancel. That was the whole point of doing this. And then I've still got 4 minus, and again, what's that I squared? It's negative 1. So hopefully here, this is really a negative 10 and a positive 14. So I'm looking at what? That's just 4 minus 39i. And then on bottom, that's a negative, and a negative is a positive, so that's 29i. There we go right there. Final answer, i's out of the bottom. That's a simplified form. If you want to break that into two different fractions, you can. You can say 4 over 29 minus 39i over 29. Awesome. So that would be like the standard form of it, a plus bi. Super. Moving on. I know I'm going quick, but hopefully it's a review, so hopefully you're okay with this. Then we start solving these quadratics. Remember, this is the standard form of a quadratic. Quadratic just means it has the highest power of 2. So when I solve this, what do? Well, you got to get that by itself. So we're going to solve first by square roots. And really, that's just when you only have like an x squared term. That's when you kind of use this solving by square roots. So that's it squared. And that's negative 16. And then when I get this square by itself, what do? I do the opposite. So I square root it. So this is 2x plus 3 equals the square root of negative 16. So the first thing, when you introduce the square root, now it's plus or minus. If it started there, it's just plus, but you introduce it, so it's plus or minus. What's the square root of 16? Well, it's what? In this case, 4i. Why? Because the 4i times 4i is 16i squared, so I'm good to go there. Awesome. Once you have that, let's just wrap it up. I'm still solving for x, so I'm going to subtract 3 from both sides. So those cancel, so I've got 2x equals negative 3 plus or minus 4i. And what's the last step here? Divide everything by 2. So really, x is going to equal, and I'm going to split this fraction, negative 3 halves plus or minus, what's 4 divided by 2? It's 2. It's that bad boy right there. Excellent. So there's a nice two imaginary solutions. Remember, that actually means negative 3 halves plus 2i, negative 3 halves minus 2i. So I'm going to make sure you know that on the test, that it's two solutions. It's where it crosses the x-axis. Awesome. How about completing the square? Little tips I have for completing the square was go ahead and move the constant over. You know, the plain number has no variable, so get rid of it on, so you've just got letters, you know, your n squared and your n over here. That gives me 9 on the right. So now once I have that, now I'm going to complete this square. And what that means is I'm going to write something squared like this. So the rule is what? You just bring your n down and you cut b in half. Cut 6 in half is 3. So when I square this, this is a perfect square. When I multiply it out, I'm going to say 3 times 3 is 9. So you've actually added 9 to this side of the equation. So to keep it equal, you got to add it to that side of the equation. So when I do that, I'm looking at 9 plus 9 is 18. Awesome. So we complete the square. Now it's just a matter of solving it. How do you solve this? No problem. Just square root both sides. So we're looking at n plus 3 equals the square root of 18. Remember, that's like saying the square root of 9 times the square root of 2. And, well, maybe I should wait on that. Should I wait? I should wait. Let's just go ahead and solve it. My bad. Alright, so that's the square root of 18. And what happens here, though, the key is plus or minus. I introduced that, so it's plus or minus. So next step, what do I do here? Let's subtract 3 from both sides. Boom. So I'm looking at n equals negative 3 plus or minus radical 18. Pretty good answer right there, but let's simplify it some more. Remember what? The square root of 18 breaks down into square root of 9 times the square root of 2. I kind of got ahead of myself earlier when I said that. And why do I do that? Well, that's because I know the square root of 9. The square root of 9 is 3, so it's really this. Negative 3 plus or minus 3 radical 2. Awesome. Very nice. So we can complete the square. Moving on to the last one we did was quadratic equation. This whole big equation right here. Just remember, to use a quadratic equation, you have to set it equal to 0. So you have to put everything on one side of the equation. Put it in order here. And why do I do that? Because now I can recognize my a, b, and c terms. So a is the number in front of x squared. It's the coefficient there, so it's 2. b is the number in front of x, so that's negative 4. And c is the constant, which in this case is 6. Awesome. Once you've got everything labeled, just plug and chug. We've got negative 4, so that becomes positive, plus or minus the square root of what? negative 4 squared. I put that in parentheses when you have that negative there. Just make sure you get your signs okay. Times 4, I'm sorry, minus 4 times AC. So I've got this all over 2a. And then it's just a matter of simplifying. So I want you to be able to simplify these things down. See what we get here. We've got 4 plus or minus negative 4 squared is positive 16. Be careful if you're using your calculator. Negative times negative is always positive. Minus 8 minus 48. Is that right? 4 times 2 times 6. All that's over 4. And then it's just a matter of, can we simplify this thing down any? I think we can here. So we got 4 plus or minus, what is 16 minus 48? Is that minus 32? All of that's over 4. And let's go ahead and break that down again. What is the square root of negative 32? Well, that's going to be what? It's going to be imaginary because it's negative. And I think we're going to say, what, 16 times 2 is the biggest power that goes into there? Biggest perfect square, sorry. So something like this. And what does that give me? Well, I know the square root of 16, that's why I did it, is really 4i over 2, all over 4. And then what do we do here? We'd like to split these things into two fractions. So I've got 4 over 4 plus or minus 4i radical 2 over 4. Lots of canceling here. 4 over 4 is just 1. Those 4's cancel, so I'm left with 1 plus or minus I radical 2. I love it. Love it. So quadratic formula always works. You know, sometimes you can factor, sometimes you can square root. This always works. You can always do this when you're good to go. All right, the last one is solving by graphing. So I just realized I didn't pull up my graphing calculator. Rookie mistake. Okay, the last one's solving by graphing over here. So I have this equation. So if I want to solve it by graphing, once you set it equal to 0, you can graph it. You can just say, hey, yeah, this is really y equals x squared minus 6x plus 7. So if you want to solve this using, completing the square quadratic formula, you can solve it. But here are the answers. I already pre-solved it. These are my roots or my solutions. So I know it crosses here. How can I double check that on the calculator? Well, if you graph it on the calculator and zoom standard, we've got something like this right here. So we can actually find these roots. This over here, this is an exact value. 3 plus the radical 2 is the exact value of this. So the calculator will actually show me the approximate value, which turns out to be really good. You're finding the zeros, you're finding the roots here. So what I do is I try to get myself right on the root. This is where it crosses the x-axis, so I try to get as close as I can. And then it says left boundary, so hit left like 3 times, so I'm left of it. Then go back to right where I'm on it. Then it says right boundary, so hit right a couple times. Then hit enter. It wants you to guess. If you want to go back to guess, you can, or just hit enter again. And it tells me, boom, that is one of my roots right there, 1.58. How about the other one? Well, just repeat the process. Keep coming back. We're finding the 0. Come on over here. This is where I think the root is. Pretty close right there, but it wants the left boundary because it doesn't know where to look. There's 2 of these roots, so you got to come back here and say left a couple times, hit enter, go back to the root, and then I want the right boundary, so hit right a couple times. So it's nothing to do with up or down, it's always left or right with a calculator. Guess, you can just hit enter, and it tells me my other one right there. So here are my 2 roots. Boom, boom. So I said earlier that I found this, and I got 3 plus radical 2. So let me slide this out of the way here so we can see it. So here are the 2 roots right there by graphing. Now I said that when I found it, it was actually 3 plus the square root of 2. Was I right? Let's check it out. 4.41. See, there it is right there, 4.41. And then the other one was 3 minus, square root of 2. So if I put that in, aha, I was right. So the calculator is really good at going ahead and giving these decimal approximations. They can't give you this exact value because this is an irrational number, so you can't like math frack it or anything magical here. But it does help you, find out, if you get the exact, make it a decimal, or you can double check it here. Now I know my roots are about 4.41, and the other one was 1.58. You can even use it to help you find the vertex, or you can just do the axis of symmetry, plug and chug. If you want to use the calculator to find the vertex, no problem. We're just looking for what? In this case, we're looking for the minimum point. So we're looking for number 3. And again, it's a left bound, right bound kind of things, because later on we'll have multiple minimums or maximums. So here's the minimum right here. I want to be left of it, so hit enter. Then I want to be right of it, hit enter. Then it wants you to guess, hit enter again. And sometimes the calculator does this. It's a little bit off. So if you see this, 3.000014, well, really it's just 3. The calculator just got a little bit off in its calculation. So it's really at 3, negative 2. So there's the vertex, and now I know the roots. In this case, I could still do my 1, 3, 5 rule here, but I got extra points, which is always nice, where it crosses the x-axis right there. So my parabola looks something like this. So graphing, especially with the calculator, can be a huge help. And I think that's it. Good luck on the test. I hope it goes well. Peace out.